Let's see what we're looking at here. It looks like it is a proportions problem where we're going to try to find x. I didn't include the directions, I just have the diagram, but I know that's what we are supposed to do. This is a similar triangles problem. And technically, in order to be able to do this, we would need to know a few things about the triangle. So there's two triangles here. It's pretty important that we can see them. So I'm going to kind of shade this one in a little bit here in yellow. So we got this small triangle here on the top, and then sort of included around it is a larger triangle. Now I'm saying that these are similar, but they really don't have any notation until we know that this angle, which is part of both, it's part of the small triangle and it's part of the large one. And then this set of angles, oh, I gotta triple it now. I don't want to show that they're all three the same. I just want these two to be a congruent angle pair, and then this to be a congruent angle pair. It's part of both. So now we actually do have them congruent from angle, angle, similarity. We have two pairs of corresponding congruent angles. So now we can actually solve for our missing pieces. Now for some of you guys, you'll be able to set up the proportion based right on what you're seeing. So I'm going to do that here, and then if you're not sort of seeing it, I'm going to draw the triangles separately and show you how they work. Okay, so what we're looking for here is corresponding pieces to solve a proportion. On my solid triangle here, this length here is 6. And then if I do the corresponding piece on the big one, it is actually the full 6 plus x. Oops, I need that to be a plus, and I do it like 6 times x. So I can fix that here. So it really should be 6 plus x, because it's that full length. It's this and this together. And then I can set that equal to the bottom part of the triangle, which is 3, and then that corresponds down here to 5. So hopefully what you can kind of see here, right, is that this piece corresponded right to here. That's the 3 to 5 section. And then when I look on the left side of the triangle, this is on the shorter version, and then I have to go all the way down for the outside, which is why it is 6 plus x. Now, for some of you guys, that'll be very clear. For others, you might need to draw the triangles separately. So I will do that sometimes, and I'll draw like a version of the top triangle, and then I'll draw a version of the bottom triangle, and how we can see them as two separate things. And then this is 6 and 3. And then this bottom here is 5, right? That's corresponding right down to here, the 3 to here, the 6 to there. And then this is the full 6 plus x. So from this, it might be easier to tell that the 6 corresponds to the 6 plus x, and then the 3 corresponds to the 5, and that's where I get those proportions. But whichever way you visualize it, this is a correct proportion that you can set up. In order to solve it, we're going to use cross products. So I'm going to do 5 times 6, and that's going to equal 3 times 6 plus x, right? It is this cross and this cross, and it's cross product, so it's their product. You get 30 here, 18 plus 3x, and then I'm going to subtract 18 from both sides. Move it up just a little bit. That's going to give me 12 equals 3x. Divide both sides by 3. And I now have x equals 4. And that is my final answer. I solved for that unknown piece on this triangle, this sort of section right here. It's just this little piece right here. So that would make this full side then 10. Okay, hope that's helpful. Message me anytime with questions.